I know this module is called Administration Automation using Ansible, but it's not really about Ansible. Sure, we'll be using Ansible to perform some important tasks, but the real topic is orchestration automation, and Ansible is just one of the tools we'll use to get it done. But why is this kind of automation such a big deal these days? I'd say there are two reasons. First, the resources consumed by modern microservices workloads are becoming much more complex and encompass far more instances than ever before. And second, more and more of those resources are virtual rather than physical, so many of them will exist for minutes or even seconds. All of which means that even if you wanted to go around logging into each of your many servers, it just wouldn't make sense, or in most cases, be possible. Instead, you're going to be running a lot of clever scripts, and the tools we use to run those kinds of scripts are generally called orchestrators. I'm sure you've encountered at least one or two members of the Orchestration Club. Besides Ansible, there's Terraform, Chef, Puppet, and others. There are also lower-level tools that work as add-ons to core Linux tools like SSH, although seeing how it'll run natively on Windows and of course Mac OS, I'm not sure it's quite correct to call SSH a Linux tool anymore. One of those SSH add-ons is a toolset called PSSH, which stands for Parallel SSH. We'll see more of that in the next clip. For now, though, I'm going to tell you a bit about the lab I'm using so that you can more easily reproduce it and follow along at home. If you're watching this while hanging onto the bus strap on a commute, then it might be a bit more difficult, but I'm sure you'll do your best. I've got 3 Ubuntu containers running, one called Ansible 1, one called Ansible 2, and the third, all together now, called Ansible 3. Ansible 1 will be the base for all of our operations, while Ansible 2 and 3 will be the host nodes that we'll be remotely provisioning. As you can see, Ansible 1 was assigned the 10.03.140 IP, 2 got 10.03.93, and 3 got 43. Everything we'll do assumes that we've got passwordless SSH access from Ansible 1 to each of the 2 nodes. If you're not sure how to do that, you can view the SSH module of my Protocol Deep Dive SSH and Telnet course. If you're in a hurry, this Red Hat tutorial will get you to the same place. You only need to install Ansible on your base machine and not on the nodes. That simplifies things significantly. In my case, Ansible is already installed, so we can save ourselves some time. Ansible -- version shows us, first of all, that the package is happily installed. We can also see the installed version, where the Ansible config file is, and the version of Python Ansible wants to use. Because Python 2 still hasn't quite disappeared off the face of the earth, that'll cause us some grief before we can get properly started, but we're off to a good start at any rate. In the next clip, we'll perform some actual remote orchestration to see how it all works. As advertised, we're going to try 2 separate tricks on this demo. First, we'll install the PSSH package and execute a couple of useful commands on my nodes, and then we'll use the Ansible that we already installed to turn our nodes into web servers. Okay, so I know that I called these containers Ansible 2 and 3, but I'm going to use them for PSSH 2, and I hope I won't offend anyone in the process. Here's how you install PSSH. No great wisdom there, and in any case, it's already installed. I created a simple host inventory file called sshhosts.txt that contains the IP addresses of my 2 nodes, or hosts, or whatever else you might want to call them. Once again, if you're following along with me at home, make sure you've got passwordless SSH access to the host before you begin. Now I'm going to run the PSSH Parallel SSH command to execute a single command on my hosts. -I tells the program to run as interactive. Otherwise, we wouldn't be shown any command output. -h points to the hosts file that I called sshhost.txt, and the command itself will be the old Unix utility df. That'll return a list of drives attached to the system along with their mount points and usage information. The -h here will display disk space in human-readable units, and the t will restrict access to only drives formatted as ext4. Why do I care about that? Because Ubuntu uses the Snap Package Manager, and each snap creates its own virtual device. So what? Well, I don't want to have to comb through a dozen or so virtual devices reporting 0 free space just to get to the real drives reporting actual usage. And there you go, full disk space information about both of my nodes. I'm sure you noticed that the information is identical. That's because these are both containers running on my workstation, so as far as they know, they both have full access to my own drive. For my next trick, I'll collect the etc/group files from each of my nodes. This is the kind of operation that could be useful to quickly monitor the security status of your nodes. You could add a script that parses the incoming data and alerts you if there are any anomalies. Before I begin, I'll create a directory locally called host-files. Then I'll use the parallel-slurp command, whose name deliciously describes its function. Again, -h points to the host file. The -l sets the host files directory as the target location for writing the data we're going to generate. etc/group is the remote file we want to slurp up, and group is the name we'd like to assign the data locally. When it's done, you can see host files now contains subdirectories named after the IP address of each of my nodes. I'll drop in, and as you can see, there's a file called group that contains the etc/group data from this node. Does PSSH come with any other treats? You bet it does. And here's the whole list. I'm honestly not sure how fair it is to characterize Parallel Slurp and Parallel SCP as kill programs, though. Next up is Ansible. Ansible also works from an inventory file listing my hosts, which by default lives in the etc/Ansible directory. As you may already know, you can divide hosts into groups to more finely tune your operations, but this isn't an Ansible course, so you won't go there. My file contains nothing more than those node IP addresses. Oh, and one more thing. Remember how I said that the Python 2, Python 3 thing was causing some confusion? Well, this is the only way I've found to clear it all up for Ansible. If you'll be using a more recent release of Linux, you may not need to worry about this. Let's make sure our configuration works. This command will list all the hosts from the hosts file. That looks right. Next, we'll want to confirm that we can ping the nodes. Everything looks good. Now let's do something fun. The webserver.yaml file is an Ansible playbook that will assume any necessary sudo powers when it executes on the remote host. There are only two tasks it'll run. We'll install the Apache web server and then start it up and set it to launch on every reboot. That's it. I'll execute the playbook using Ansible playbook and wait for all the action to complete. Did it work? curl tells me that there's an active web server on 10.03.43. And just to be different, I'll open 10.03.93 on my browser. One command, two web servers. You could, of course, just as easily do this for 100 or 1,000 hosts, and you can also populate your web servers with fully composed content. I'd say that's pretty impressive. Find this useful? Why not follow the link in the description and head over to view the complete course on Pluralsight. And of course, for even more technology goodness, don't forget to subscribe to this channel.